I can use models to show equivalent fractions. Let's look at this lesson's essential question. How can you use models to show equivalent fractions? Well, let's begin by reviewing. What does the fraction 4/6 represent? Turn and talk to your partner about this. So what does the fraction 4/6 represent? Well, it represents 4 of the 6 parts of a whole. And what does the fraction 6/6 represents? Pause this video and turn and talk to your partner about that. Well, 6/6 represents 6 of the 6 parts of a whole. In other words, you have the entire whole. So let's look at this following word problem found on page 327 in your book. If you need to get your book, pause this video until you're ready. Okay. Joe cuts a pan of lasagna into third-size pieces. He kept 1/3 and gave the rest away. Joe will not eat his part all at once. How can he cut his parts into smaller, equal-sized pieces? So the first thing, as always, is to identify the question part of the word problem. And there's that question mark, and there's that beginning of the sentence, so that is the question part. So let's box that so we can keep focused. And let's reread that. So, how can he cut his part into smaller, equal-sized pieces? So we need to figure out how he's going to cut just his part into smaller, equal-sized pieces. Now, let's look at the rest of the word problem and figure out which are the important information needed in order for us to solve this problem. So rereading, it says, Joe cut a pan of lasagna into third-size pieces. So that is important for us to know. The pieces are third-size pieces, so we underline that. Let's continue. He kept 1/3 and gave the rest away. That is also important. He didn't keep the entire lasagna pan, he only kept 1/3. And the rest was given away. Joe will not eat his part all at once, and that is why he wants to cut it into smaller, equal-sized pieces. So that makes sense. So remember, the first thing that you need to do in order to solve word problems is to think about it until it makes sense to you. So, basically, in this investigation, you have to find other fractions that name the same amount as or are equivalent to 1/3. So let's begin by first drawing on a model to show, first of all, the lasagna, then Joe's part of the lasagna, and then how he could cut his part of the lasagna into 2 equal pieces. So go ahead and open up to page 327 if you haven't done so already. Pause this video until you're ready. So first of all, we can just simply draw a rectangle to represent Joe's lasagna. Now remember, in the first part of the word problem, it says that Joe cut a pan of lasagna into third-sized pieces. So if this is his pan of lasagna, we have to cut it into thirds. Thirds means 3 equal pieces. So let's go ahead and do that. So we can simply just divide our rectangle into thirds. So there we have 1 piece, and then we have another. So now we have 1/3, 2/3, 3/3. Now, let's go back to our word problem. And this is something that you need to do when you're solving word problems. you have to continuously go back, reread it, make sure that you are applying the correct information into your problem solving techniques or strategies. Okay, so Joe cut a pan of lasagna to third size pieces, which we've done already. He kept 1/3 and gave the rest away. So he really just kept the smaller portion and gave away the greater portion. So how much did he keep? Well, he kept only 1/3. So let's shade in the part that he kept. So just 1/3 would just be, let's say, this portion right here. So we're shading in the portion he kept just so that we don't get confused. So if he wanted to cut his part, which we know by now is just the shaded part here, because again, he kept 1/3 and gave the rest away. This part he gave away. This is his portion, but we're leaving this whole lasagna pan here just so that we can make sure that we're understanding the fractional pieces we're talking about. So this is his part right here, which is 1/3. He can cut it into 2 equal pieces. So if we're taking this part, let's go ahead and cut into 2 equal pieces. So it would look something like this. So now he has his 1/3, but we cut it into a smaller equal piece, which is 2 parts of that 1/3. Now, how many pieces would there be if he cut the original pan of lasagna into equal pieces of this size? Pause this video and turn and talk to your partner. Okay, so suppose Joe had cut the original pan of lasagna into equal pieces of this size. How many pieces would there be? Well, let's see. If he did that, it would look something like this, right? So how many pieces are there? 1, 2, 3, 4, 5, 6. There would be 6 equal pieces. So each fraction of the pan is 1 out of the 6. So the fraction of that one piece would actually be 1/6. Well, if we're talking about his portion, it's both of these parts right up here, 1/6 and 1/6. So how much is 2 of these 6's? Well, that would be 2/6, 1/6, 2/6. So we can rename Joe's part of 1/3 as 2/6. Okay, so is this the only way that Joe can cut his part into? Just in 2 equal pieces? Well, no, right? Let's see how Joe can cut his part of the lasagna into 4 equal pieces. So go ahead and try this with your partner and pause the video until you're ready, and then we'll work on it together. Okay, so here is another model of the lasagna that he made. Remember, he cut it into thirds, and we shaded in the portion in which he decided to keep, which is basically just 1/3, since he cut the whole into thirds and he kept the one piece out of the three equal pieces. So if you wanted to cut it into 4 equal pieces, then it would look something like this. Now suppose Joe had cut the original pan, right, the entire pan of lasagna into equal pieces of this size. How many pieces would there be? Pause this video and turn and talk to your partner. So how many pieces would there be if Joe had cut the original pan of lasagna into equal pieces of the size? Well, there would be 12. Let's look and see why that would be. So he would have cut it this way, and this way, and this way. So let's go ahead and count those pieces. So we would have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So therefore, what fraction of the pan is that one piece? Well, because there's 12 pieces, we know that the denominator would have to be 12. And if we're talking about just one piece, the numerator would be 1. So the fraction of one piece would be 1/12. But now we're looking at Joe's part. He has 4 1/12. So what fraction of the pan is 4 pieces? Pause this video and turn and talk to your partner about that. So what fraction of the pan is 4 pieces? Well, that would be 1/12, 2/12, 3/12, and 4/12. Therefore, we can rename this 1/3 as 4/12. Fractions that name the same amounts are equivalent fractions. So, in other words, we have learned that 1/3 is equivalent to 2/6 and is also equivalent to 4/12. Now let's take a deeper look into the fractions 1/3 and 2/6. Let's compare the models also. So we're looking at 2/6 and 1/3. How does the number of parts relate to the sizes of the parts? Pause this video and turn and talk to your partner. All right, so how does the number of parts relate to the sizes of the parts? Well, let's look at the model for 2/6, right? Which is basically these smaller parts here. 2/6. Well, the model for 2/6 has twice as many equal parts as the model for just the 1/3. Right? The yellow is the 1/3. And the parts are half the size. Now, describe how the numerators are related and how the denominators are related in 1/3 and 2/6. Pause this video and describe to your partner how the numerators are related and how the denominators are related in 1/3 equals 2/6. Pause this video until you're ready. Okay, so hopefully you discovered that a whole divided into 6 has 2 times as many parts as a whole divided into thirds. So the numerator and the denominator in 2/6 are each twice the numerator and the denominator in 1/3. So basically, if we're talking about 1 as a numerator, twice as much as 1 is 2, since 1 plus 1 equals 2. And twice as much as 3, so we're talking about 2 groups of 3, or 2 times 3, or 3 plus 3, and that makes the 6. Now here's another question for you. Does 1/3 equal 3/9? Pause this video and turn and talk to your partner about that. Does 1/3 equal 3/9? Okay, so does 1/3 equal 3/9? Well, yes, it does. A fraction with 9 in the denominator has 3 times as many equal parts as a fraction with 3 in the denominator. So, basically, 1 times 3 equals 3, and 3 times 3 equals 9, so 1/3 does equal to 3/9. Now let's look at another problem. Savannah has 2/4 yard of ribbon and Isabel has 3/8 yard of ribbon. How can you determine whether Savannah and Isabel have the same length of ribbon? So let's look at our question again. There's that question mark. There's the beginning of the sentence. So there's our question. So let's box that and read that question again. How can you determine whether Savannah and Isabel have the same length of ribbon? So basically, we need to figure out if their ribbon length is the same. That is our task in this word problem. So let's go back and figure out what is the important information. So rereading, it says, Savannah has 2/4 yard of ribbon. That's pretty important. So let's circle that number and underline what they're talking about. 2/4 yard of ribbon. Isabel has 3/8 yard of ribbon. So let's circle that 3/8, and we're talking about yard of ribbon, and that is super important as well. So, how can you determine whether Savannah and Isabel have the same length of ribbon? So if we're making comparisons, we're going to be using the equal sign to say that it is equal or equivalent, and we're going to use an equal sign with a slash through it if we want to show or represent that fractions are not equivalent. So let's get back to our problem. We have to tell whether 2/4 and 3/8 is equivalent. So let's look at models. So here I have a model for Savannah's ribbon and a model for Isabel's ribbon. Notice, and this is super important, that the models are exactly the same size and length. Remember, when we're talking about fractions and we're comparing, we're talking about a whole in which it is the same amount or length. So let's begin with Savannah's ribbon. So Savannah has 2/4 yard of ribbon. So let's suppose that this is a yard and this is also a yard. Remember, it has to be the same length. Since Savannah has 2/4 yard of a ribbon, we're going to divide this into fourths. So we'll have something like this. Okay, and let's label it on top. So we can simply use a line, and we know that this is 1/4. This will be 2/4, 3/4, and if we get all the way to the end here, that's 4/4, which is one whole, and from here, that's 0/4, obviously. So we have from here to here is 1/4, right? 2/4, 3/4, and 4/4. So Savannah would have 2/4. Okay. So again, she has 1/4 and 2/4. So now we see how much Savannah has. Now, let's take a look at what Isabel has. Isabel has 3/8 of a yard. So in other words, we need to divide this into eighths, not into fourths. So let's begin. So let's divide it in half. And then we begin with fourths. And then again, each piece into another half. And that's going to give us 8 equal pieces. Let's do the same as we did above, and let's go ahead and label it with a line. So we know that this obviously is 0/8, and all the way to the end would be 8/8. So now we have 1/8, 2/8, 3/8, 4/8, 5/8, 6/8, 7/8, and finally the entire piece would be 8/8. So let's see the amount of ribbon Isabel has. So it says here that Isabel has 3/8. So let's go ahead and shade that in and see what that looks like. So up to here, 3/8. And we could clearly see from the number line here that this is 3/8, this length here. And we can also count it as 1/8, 2/8, and 3/8. Now we can clearly see Savannah has 2/4. Is that the same as 3/8? No, right? The parts representing 2/4 reach a point on the number line here that is farther from 0 than the parts representing 3/8. So we could tell with a model that it is not equivalent, so we can actually write down that 2/4 is not equivalent to 3/8. But let's say that we just wanted to look at the numerators and the denominators. How can we tell that 2/4 and 3/8 are not equivalent? Pause this video and turn and talk to your partner. Okay, so how can you tell 2/4 and 3/8 are not equivalent using the numerators and the denominators? Well, the denominator in 3/8 is 2 times the denominator in 2/4, right? 4 times 2 equals 8. But the numerator in 3/8 is not 2 times as the numerator in 2/4 because 2 times 2 would be 4. So if we really wanted to figure that out using the denominator of 8, well, 2/4 would be equivalent to, well, what's 2 times 2? That'll be 4. 2 times 2 would be equivalent to 4/8. And you could clearly see that right here. 2/4, 4/8. So let's get back to our essential question. How can you use models to show equivalent fractions? Pause this video and turn and talk to your partner. In this video, you learned how to use models to show equivalent fractions.